Okay, today I'm going to implement the Connect4 game. I have prepared here some tests for the video. Well, let's get started. To initialize our board, we'll need a specific width and height. Self dot width and self dot height, and with that we can initialize our board that will start with all empty values. Okay, and I will implement here a display function to help me to debug if something goes wrong. Okay, and print self.board, and let's see if this is working. Display. Uh, uh, okay, okay, I need to set up some default values here. Let's say 10 for width and height. And we have here our board with all empty values as expected. And I will format this function a little bit. So, and I will have here a variable is an empty string, and I will be adding every cell value. Print. I have to print this. Okay. Okay. We have here our board. Everything is working correct. Okay. For playing in the game, we have just a function play where basically every player has to drop their token in a specific column, and we have to place that token in the lowest empty row. uh, I will create a function here. uh, get get first empty row, and it only needs a column. Okay. And once we get the row, we can place the token in that cell. Self.board. Uh, okay. We need here a variable to set the current player. Let's say we'll start with player one, for example. uh, and after every movement, we need to switch the player. Okay. And to implement this function to get the first empty row, we need to iterate for in a specific column backward, because we need to get the lowest empty row value. So I will do that with a for loop, so I can also ensure that I am always within bound and I don't get a index error. For row self dot high, and it's going to be, I'm going to iterate this backwards. Uh, if the cell is empty, when return the value. If self uh, row. Okay, let's see if this work. I have a test here. Test no winner. Uh, test no winner. Okay, it's working. Okay, so well, after every movement, we have always to check if there is a winner. Uh, I will create a function here to check if there is a winner. Def is winner. Okay, and to check if it's a winner, we need to the parameters, the route call, and the current player that we want to check. And if it's a winner, we return with the winner. Current player, and we print here uh, player self dot has one. Okay, and to check if it's a winner, we need to check if we have a line of four in any direction in the column or in the row, and in the both in the increasing diagonals and the decreasing diagonals. Uh, row call current player. Well, we need to iterate for all the possible directions that there could be it could be a winner. So I will use here a list directions. So here for checking in the column, if we have a line of four, we have to move always up and down. And for the row, it's the opposite. And for the diagonals, we have the increasing diagonal and the decreasing diagonal. Okay, and we have to check how many token of the same current player we have in a specific direction. So I will implement here a function to get that, get or count direction, and I will have a counter for that. Well, uh, okay, and we have to check. Well, for example, if we are checking if there is a winner in a row, we have to check, for example, for this position, we have to check for the right and for the left. So we need to use twice this function. Uh, well, count, count directions. Well, uh, and the direction. Okay, and if this is if you are checking, for example, the here a row, for example, we are checking the horizontal line for the right side, and we also need to check the left side, and we need to use the opposite signs for in this case. And if this counter is equal or greater than that 4, it means we have a line of 4 in any of these possible directions. So we'll return true because there is a winner. Okay. Uh, to count direction, we have to, well, we have to be aware always that we are within bounds and we have a line of always the same current player. Uh, so we'll have here, we have here a pointer to iterate through the board, and we have to check that we are within bound. So I, uh, start with, we need to check all that we have always a line of the same current player here. Uh, Current player is equal to self.board in, in this in this cell. Okay, and we have here a counter that will start in one because uh, here we have already count we are counting here the first cell that the user where the user placed their token. Right, we increased our counter and we have to move our pointers. Okay, so here when we check if there's a winner, we check in the four possible directions. We check both for the left and right side, or if it's, for example, if it's a column for the up and down side. And when we count the direction here, we check that we are using that we have the a cell of the same player and that we are always within bounds, so we avoid any possible index error. And if there is a winner, we return. Otherwise, we change the player. Okay, so let's see if this works. Uh, test test the row, and it's not working. Why? Uh, cells, row call current player. Okay, it takes 6 positional arguments, but 7 were given. It's missing row call current player, direction row, and direction column. Okay, it itself isn't necessary. So here. Uh, Okay, we're testing here the row and search. Okay, so let's put the print here. Uh, okay. Okay, so we are counting here. Okay, because we start the counter here with one, and we are adding one twice here because we call the function count directions twice. So it has to start in here in so this it has to start in 0, and here it has to start in 1 because we are already counting the the cell where the user drop their token. Okay, this is working. Test, test, decreasing diagonal, test, increasing diagonal. Okay, it's working. That's it.